the very first thing we did, way back when. Ryan, do you want to flip a light off so we can see this a little better? Okay, we talked about if things were polynomials or not. And we've kind of been looking at polynomials nonstop since then. And we've looked at degree a lot last week. When we were graphing these, that was always one of the questions. So all of this stuff we've kind of seen before, but let's kind of go through it. The things that are required to be a polynomial means all of your exponents have to be positive integers. So like 0, 1, 2, 3, 4. So is A a polynomial? No. Why? Oh, that's way too pretty color.
Nice.
All right. Is B a polynomial? Yes. Now, if it's multiplied like this, to find the degree, you have to think about if I multiplied it out, what would my highest exponent be? So if we multiply this, we have 2 x's in the first parenthesis, 1 here and 1 here. So the degree is 4. When they're added and subtracted, you just take the highest term. When they are multiplied, you have to put them all together. By the way, I didn't ask, or I did ask, what's the end behavior going to look like on this? Down, down. Even degrees look like parabolas, and the -3 flips it upside down. Now, end behavior. Some of you have struggled with that. What do you do if you don't know your end behavior? Graph it. Can you plug it in your calculator and tell me which direction the ends are pointing? Yes. So we have a way of getting it if you get confused. Okay, C, is that a polynomial? Yes. What's my degree? 5. Careful, it's not just the first one, it's the highest one, so it was a 5. What's the end behavior here?
Down that.
Okay, is D a polynomial? Yes. What would be the degree on this one? Oh, hold on. Is end behavior right on C? Yeah, remember your highest power was in the middle. You can't just look at the beginning.
Oh, no.
It's up, down. See, I told you guys, I make mistakes too. And you guys didn't even question it.
Well, I don't have to made mistakes.
D, what's the end behavior of this one? It's an odd, so it looks like a cube. There's not a negative, so it doesn't flip. So down, up. Evens look like parabolas, odds look like cubes, negatives flip. Yeah, the weekends. Okay, number 2. Really hard to see my graph here, but it looks something like this. Minimum possible degree. Okay. Do you?
Yeah. E.T. Oh, no. I saw your shoulder. I'm sorry.
You were giving a minimum point.
Yeah. Negative infinity.
That's in, you're thinking,
So I'm laughing at
Okay.
I'm laughing at you.
I want the smallest possible degree. So degree up is just a number, like 2, 3, 4. Remember, we had this relationship between degree and turning points. If you think about like a parabola, it has degree 2. How many turning points does a parabola have? 1. A cubic is kind of misleading, but a degree 3 could look like this. How many turning points does this have? 2. The smallest degree is 1 more than the number of turning points. How many times does this graph change direction? 3. So the smallest possible degree is?
I thought I was talking about the points.
We're getting there later on. Domain. As you go from left to right, this keeps going in both directions, so domain. Range. From the bottom up. So this keeps going down forever, so it goes from negative infinity.
To whatever AB is at.
Yeah, so it would just be the y value of that point. That would be the highest y value you reach. So it's from negative infinity to b, whatever b is. Because range talks about your y. Why did I what? Yes.
Oh, so the range is done.
Yeah, range is done because it was just low to high. It's going to go down forever. The highest point we hit is right here, and its y value is b. Okay. Then we talked about local versus absolute maxes and mins. So local extreme. We're talking about local max, local min. Those are just higher or lower than the points around them. So what would be my local max? Yes,
AB.
AB. Any other local maxes? CD.
I thought we were talking about the highest.
This is local, just means higher than what's around it. Absolute means the actual highest. All right, what's my local min? I think it's EF.
Well, it just takes the homework.
You can call it T if you want. Maybe it is T.
No, it's AT.
Whatever you want to call it. T, F, something like that. All right, absolute. That is the actual highest or lowest your graph reaches. So the absolute maximum point. Yes.
On the local minimum,
Mm-hmm.
why would CD not be lower?
Because it's not lower than the point surrounding it. It's higher. When you're talking about local, you are not looking at the entire graph, you're just looking at this portion surrounding it, and it's higher than those points surrounding.
Okay.
Other questions there? Absolute max?
AB.
Oh, that's not the same color I had before. That's not pretty. Alright, absolute min? Is it?
Infinity.
Okay, so the local is the local max is the highest point, and then so what's the absolute?
Local is just surrounding it, meaning it's higher than the points on either side of it. Absolute is the actual highest or lowest your graph reach. So my graph never hits anything higher than AB, so that is my absolute max. Absolute min, does it have anything lower than EF?
It's, oh, wait.
Yeah, these ends are going down. Is there an absolute min? None. No min on that one. Okay. Questions on that stuff? All right, let's look at question 3. We are writing a polynomial. -3 is a 0, so we are going to write what? Multiplicity 4, 1, multiplicity 3, and 0. If 0 is a 0, what do we put? You put like x minus 0, but that's the same as just x, so you can put a plain x. Okay, we said the degree had to be 8. Is this degree 8? Yes. So I met the requirements of 8. I'm done. Okay. Question number 4. We did these on that Chromebook activity we did Friday. Writing equations for the graphs. So, if I look at this one, it touches the x-axis at -2, so that means it needs, and it bounced. So that means it is even power squared. Okay, the next place it touches the x-axis, 3, so we would put, okay, am I done? Right, this in behavior doesn't match a cube, it's flipped, so we know it's a negative in front. Now what if I wanted you to find what coefficient was exactly? Where does this thing touch the y-axis? Okay, so the point 0.04 is on this. Could we find, if we just called this an A out in front for the moment, could we find A? Okay, so we know A is going to be a negative, but if I wanted to find it exactly, you put in a 0 for all of your x's. We have to get out 4. 2 squared is 4. There's -3. Divide by -12. And that's -1/3. So our overall polynomial is -1/3 times x plus 2 squared times x minus 3. Do you remember doing that on Friday?
Yeah, but which one would we need to do? Like, if it doesn't ask for the A, do we not have to do it?
If you're not sure, you can always ask me and I'll clarify. If I give you a graph that has the y-intercept, I would like for you to find A. Other questions? Is this stuff all coming back? Even though it's stuff we did before Christmas, we were using it all last week, so it's not totally new to us. Okay. What is the quotient when x to the 6th minus 16x to the 4th plus x squared minus 16 is divided by x plus 4? Synthetic. What are you going to put out in the box? And our coefficients will be good. Don't forget those zeros. So 1 comes down. 1 times -4 is -4. And add. You guys all remember synthetic division, right?
Yeah.
We've been doing that a lot. So remember, this is your remainder, your constant, and then increasing powers of x. So our quotient, which is x to the 5th minus 4x to the 4th. If there's zeros, you can leave them off. So plus x minus 4. What's the remainder here? 0. If it was something else, if it were like a 10, you would do plus 10 over what you were dividing by. So then the other question I asked, is this a factor? What does it mean to be a factor? Right. Divides evenly, the remainder is 0. So this one is in fact a factor. Okay. Any questions there?
How do you know when you're supposed to do synthetic division?
This one was just asking us to divide by x plus 4. We did multiple ones sometimes when we were working with our polynomials. Do you want to do an example like the stuff, the 4.3 stuff? Okay, let's do one there. And that'll kind of answer your question. So you can just add it to this page if you want. let's say I give you this. I'm going to give you a problem where we have to do everything on it. What is the degree of this? If it's added and subtracted, you just take the highest one you see. When they're multiplied, you have to put them together. When it's added and subtracted, you just take your biggest. So the degree is 4. So the in behavior, even degrees look like parabolas. It was a positive coefficient, so in behavior would be up. Okay. Let's find the possible zeros. That's the new thing we're doing when we had to do our P's and Q's.
Thank you.
So, your P values, where do you look at to get those?
8.
The 8. Everything that divides 8 evenly.
1, 2, 3.
Remember, we put plus and minus with each of those. Q is everything that goes into the leading coefficient evenly. And 3. How do you get the possible ones?
Divide.
Okay, P over Q. So 1 over 1 is 1. 1 over 3. 8 over 1 is 8. 8 over 3. 2 over 1 is 2. 2 over 3. 4 over 1 is 4. And 4 over 1. Remember, if you have repeats, you don't have to write them more than once. Okay. Let's say I asked you to factor this. I want the factor formula. So I'm just kind of breaking it into steps, telling you all the things that I might ask. How would I factor this, knowing my possible zeros? We used our graph to kind of narrow it down and find one that worked so we could do synthetically. So, does 2 work? Looks like it. If you're not sure if it works, remember you could just plug it back in the polynomial and see if you get out 0. But it looks from my graph like 2 works, so I'm going to start with my synthetic with 2. So now we're back to the ones where sometimes I might give you the starting point. So 3 comes down. Multiply and add. Is it down where I can do box method yet? No. So this is when you repeat your synthetic. We need another 0 that works. Or if you looked at your graph, what happened at 2? What did the graph do? It bounced. So what does that tell you about 2? It's a multiplicity of 2, so it'll work again. Let's do synthetic again with another 2.
Oops. Does that work for every number if it bounces?
Yes, if it bounces, you can automatically do it a second. So we have 3x squared plus 5x plus 2. So we go to box method. Multiply to 6, add to 5. Okay. So our overall factored form, it factors into 3x plus 2, x plus 1. What else do we need? X minus 2 squared, because it worked twice. So there's our factored form. What if I asked you for the zeros of this? If you set each parenthesis equal to 0, what makes 3x plus 2 equal 0? What makes x minus 1 0? -1, and x minus 2? 2, multiple C2. Do you guys want to keep going through all the steps we would if I wanted you to graph it? We'll just pull it all together. Would it bounce or go through at each of these? At -2/3 it will. At -1? And at 2? How do you know? The multiplicity even around. If I asked you for the y-intercept, if you plug in a 0 for all of your x's, you could do it in your factors, you could do it at the very beginning. We should get 8, I believe. And then we graph it. We said our end behavior was up, up. Get the y-axis at 8. The x-axis at -2/3, -1, and at 2. So you're starting up here, you come down, hit your graph, it went through, so you come back and hit the next one. Went through, hit your y-intercept, come back and hit the last one, and at 2 it bounced. So it goes back up. And of course you can kind of compare that with the graph on your calculator to make sure you're correct. So that's kind of everything we did last week in one big ugly problem. Any questions for me? I really just want to give you time to work on the math Excel right now. So you've got the rest of class to work on that assignment and ask questions if you need help. We do not have advisory this week.